Section 3. Now we follow a standardized step, some standardized step to do hypothesis testing. Alright? It's very standard. Okay? So please follow me. Step 1. Define your random variable x. In this case, in our case, we talk about x is the example, delivery time. Correct? Yes? And what is mu? So we define the symbols used. So, example, we let x minutes be the delivery time and mu minutes be the population mean. Correct? You define properly lah. Step 1, define. Step 2, you state what you want to investigate. Correct? You state what you want to investigate. In our case, you state this. In our case, we stated H0 was mean equals to 30, H1 mean greater than 30. This is example, right? In our example, we did that, right? Yes? So, what I'm going to say is there are 3 cases. This K is depend on your problem, okay? Don't just put K there. So there are 3 cases. One is a upper tail. You want to check whether the mean has indeed increased. Correct? Alright? Or I think you can fill in the rest. The second case is you want to check whether the mean has decreased. And I've covered it. The two-tail test is when you want to check whether the mean has changed. It's not equals to K. Then you state properly what is the percentage error you are willing to accept. It can be 1%, 5%, 10%, up to you, 2.5%, 3.85%, doesn't matter. Level of significance, I don't know. It is the probability of rejecting H0 when in fact H0 is true. Okay? Yeah, so you state what is the error you are willing to accept. And typically we leave it in percent. Actually it's alpha percent, 100%, doesn't matter. You just state whatever percent. Okay? 5%, 10%, 2%, 3%. Okay. Step 4 is the one that I don't want to explain too much first. For now, you just remember that you want to state the test statistic. Usually the test statistic, we will either use Z or T, which you have not covered. T, not covered yet. Not discussed so far. And so far we only use Z. Okay? So far we only use Z. Z is the standardized one. Okay? Okay. Then after that, you compute X bar. As I will explain later, then you do some decision making. Alright, this is decision making time. If P value is small, then you reject. P value is big, compared to the level of significance, then you do not reject. Then finally, step 6, conclude. Done. Okay? Okay. Let's go on a bit more. Okay, so how do we do? Okay, this part I will go through very quickly. Now, look. If X is normally distributed, X bar must be normally distributed. Your test statistic must be X bar minus mu over sigma over root n. It's not very easy. Done. Can? Okay, Okay. If the population is not normally distributed, that means it's not normal, not normally distributed. What do we use? We use CLT. If n is large, we can say by CLT, X bar is normally distributed. You can still do the same thing. You can still do your Z test. But you must ensure that n is large. Correct? Follow? If n is large, X bar follows a normal distribution, you can do the same thing. Okay, You want to say too much? Let's do example 1. Okay, example 1. 100 equal light bulbs is found to have a mean of 1. This is, we must look very carefully. Is found to have a mean. This is not your population mean. That means this is the mean of 100. This is what we call the X bar, the sample mean. Correct? This, if the lifetime of all equal bulbs have a standard deviation of 120, that means you assume that you know this is a population standard deviation. The question gives you a population standard deviation. Alright? And it's assumed to have 1,600 hours. This one is your population mean, and you want to test whether the population mean has decreased. That means it is now less than 1,006. Follow so far? So therein lies your problem. Correct? Somebody claimed that it is 1,006. But after investigation, you realize that it's 1570. You want to investigate whether the population mean has decreased from 1006. So we follow step by step. Step 1, from earlier, this is step 1, right? Define. Let x be the lifetime and mu be the population mean of x. Step 2, H naught. H naught must be mu equals to 1006. And this time we're going to do a lower tail test. You want to see whether mean has decreased from 1006. Level of significance. Typically, when you conduct your own test, you will decide your own level of significance, but exam problem, usually they will tell you 1% level of significance. Now, this is step 3, sorry. Yep. Step 4. Test statistic. In this case, our test statistic is Z. Okay, can you do some changes here? I know it's printed for you. Okay. When H naught is true, which means mean is 1006. If you look closely at the question did not say that the population, the X, the lifetime, is normally distributed. Nowhere is it stated. So you have to use central limit theorem to now say the X bar, because n is large, because it's 100, you use central limit theorem to say the X bar is normally distributed, and your test statistic is Z. Don't question why you want to write this. You must write. Okay? You must write. This part you definitely must write. Okay? Step 5, computation. Okay, this is the part. I want to explain. All are printed for you. I want to explain something, okay? Remember, p-value is the probability of obtaining a value as extreme as your observed value of x. Your observed value is this. Correct? So if you, where's my bell curve? Here. Okay, later I explain. So your p-value is, okay, I better draw here. Actually, what do you want? You want to see whether this is 1006, this is 1570, this is your p-value. Okay, can? So far so good. So this is to explain now, okay? These two are equivalent. This one and this one are equivalent. Correct? Okay, I want to say something. I want to be very practical here. In exam, and even when you do tutorial, I only need to see this. This. Go and write down. In exam or tutorial, I only need to see this if you can get it from GC. Okay, I want to say this. You, yeah, why? Or shouldn't write you. I say I only need to write this if GC can compute the p-value. All these parts is very good for understanding. I don't need you to write. I print it in the notes for you to refer to it and understand. If you understand how p-value is calculated, it's excellent, it's very good for really. I really think it's very good. But don't need to present all this, please. Follow. Okay, now I'm going to show you how you calculate this from your GC. Okay, so all take out GC, follow me. First step, turn it on. Second step, press stat. Stat, and then you want to do a test, right? Scroll to the right, do a test, and then do a Z test. So far we do Z test, okay? I'm not going to do anything else for now. Alright, then you key in other questions, I will investigate how to use this, but for now we use this part first, and then go down. This mu naught is what you want to test, whether the population mean is indeed 1006 or not 1006. So this is 1006. This sigma, I repeat, is your population sigma. Population, in this case, it is 120. Population standard deviation. X bar is the one you collect out of 100 test bulbs. Correct? You got the lifetime as 1570. What is your N? N is large, N is 100. You collect 100 data. And you want to do what tail test? One tail test, which is here, smaller than 1006. You calculate. Can? That p-value out. You should get a p-value. But I don't recommend that we do it blindly, but we must know what is p-value, right? You all know, right? If you follow so far, p-value, you know what it means, right? Which means it's the probability of getting a value as extreme as 1570. Now we can do some this. Then, yeah, see, done. Correct? Okay. There's some blanks here. I intend to go through very quickly. Okay, you all going to read on your own, because you don't want to say too much. Oh, okay, maybe not. Okay, wait. Okay, sorry, I'm a bit confused. Okay, now, when you calculated your p-value, this is the p-value. This is the probability of getting a value as extreme as 1570. All agree? All agree? And our level of significance is 0.01. Correct? That is the p-value method of decision making. Correct? Now, if you use the critical value method of decision making, you could have calculated this critical value, 1572.08. That means what you do is you see this 0.01, you inverse norm 0.01, you get this 1572.08. This is your critical value of X bar. Then you compare this 1570, then you still end up saying that you reject it. Not. So there are two ways. This is the rejection region. Alternatively, if you use Z, the test statistic Z, you could have decided this value. How do you get this value? 2.5. This 2.5, you can get this 2.5 minus 2.5, sorry. How do you get this? It is actually 1570 minus 1600. x bar minus 1006 divided by your 120 over square root 100. You try lah, Oh, this is your standardized Z value. Okay? And you compare against this critical Z value. This is what we call the critical Z value. You realize that you still end up the same conclusion that you reject. Okay. I'm going to say this. Okay. For exam again, there are three ways to do decision making. Okay, there are three ways to do decision making. The most obvious way, one, is this. A. Use p-value. If you can use p-value, just use p-value and compare against the number of siblings, we do decision making. B. You use x bar. C. You use Z. Don't use all three. I put in all three for lecture notes. Don't use all three. So actually I write a lot, but in the exam for this question it's very easy. You just use, I would use, if you can use p-value, just use p-value, highlighted bit, right, done, finished. Don't write a long story. Follow? So we do decision making. Now, why that? Okay. Oh, sorry, this one. Okay, so our conclusion is this. P-value 0.0621 is less than 1%, less than 0.01. Therefore, H0 is rejected. So therefore, we can safely say that there's sufficient evidence that the mean lifetime of all bulbs is less than 1006. We must conclude in the context of the problem. You cannot say H0 is rejected. Done. Cannot. Must tell story lah. Mean lifetime of the light bulb. Okay? The question also asks one thing, If you read the question on the previous page, page 9, the question asks you when to state if central limit theorem is used in testing this hypothesis. Actually, the answer is out, right? Did we use central limit theorem? Yes, we did. So, yes. Actually, quite dumb. I shouldn't let you copy this. Yes, we use central limit theorem. Just now I rewrote, right? Okay, we're done. Wow, we only did one example. Never mind. It's okay, we do a bit faster on Friday, okay? Now that we know the fundamentals, I think we can go quite fast in the example. Okay? Okay, sorry today no video because just now lecture ate up some time also. Okay. Okay, Friday. Okay? Okay, thanks.